In this video, we'll be looking at the PicoScope 7 rise and fall time advanced triggers. To illustrate the trigger, we'll be using this waveform that you see on the display. It's a low speed 1.25 kHz regular waveform with controlled rise and fall times that you see there. If we expand that waveform a little bit, use the rulers, we can see that the rise and fall time is something in the order of 155, 160 microseconds, something like that. And that is representative of a good waveform. If something other than that happens, we want to know about it. So I've set the PicoScope to run, and you can see pretty well immediately that there are some glitches in there. There is something that's going wrong. So what I want to do now is go to the next stage and use the advanced trigger to isolate those particular points that are going wrong that will perhaps enable us to correlate those errors with something else in the system that's causing it, cause and effect analysis, in other words. So I'll hold that for a moment, go into the trigger, and I'm going to move from having the type as a simple edge and select the rise and fall time trigger. And there are one or two additional settings now in addition to the source and the pre-trigger setting. There are two thresholds that I need to set for the rise and the fall time conditions. First of all, the threshold, the upper threshold, let's set that to 3 volts, and the lower threshold, let's set that was about 0.3 of volt, and you can see that represented now there on the bar. And go back in. What I want to do, I want to know first of all if there is any edges that are triggering faster than a particular time. So less than, and I can set a time here. Let's set that, say, to 100, not seconds, but microseconds, and then set the PicoScope to run. And almost immediately, well, in fact, immediately, we can see, yes, there are regular occurrences of an edge here that is definitely too fast. So if I expand that a little bit and do what we did before with the rulers, we can see in this case that I've got a rise time here of a little under 70 microseconds. So that would be representative of an error condition that is too fast in the circuit that we're trying to test. Just for a bit of fun, why don't we do it the other way around? So let's set the time condition to greater than, but this time set the time to, let's go for 220 microseconds. So, 220. Let's see what happens. And yeah, once again, we can see here there are occurrences of this edge here, which we can expand a little bit. And same trick with the rulers. Let's have a look at what the rise time of that is. Should be more than 200 microseconds. And yes, it is. We've got some of those edges now that are regularly repeating at around the 300 microsecond mark. So that also would be an error condition in the device scenario that I described before. So that's very simply how to isolate errors in rise and fall times in a device under test. Rise and fall time triggering has many applications: high-speed design, EMC compliance, pre-compliance design, that sort of thing. So it's an extremely useful tool in a lot of applications. The advanced trigger, the rise and fall time advanced trigger, is now available on all currently available PicoScope models currently on the market. So the PicoScope 2000B series, the 3000D series, the 4000A series, the 5000D series, and the 6000E series all have the rise and fall time advanced trigger. So I hope that's something that you'll find useful and enable you to debug your circuits and get your products to market even faster than before. Thanks for watching.